Good afternoon, everyone. My name is Alex Scavdahl. I'll be the presenter on today's topic. Thank you for joining us today for the webinar. It's going to be on load spreading in Femap using the data surface. To start, we'll just do a brief introduction, kind of let you know about us here at SDA. I'll talk a little bit about the data surface and the data surface editor. We'll talk a bit about the capabilities of the data surface. And today's webinar is going to be highly demonstration-based, so we'll jump right into the demonstrations. At the end, we'll conclude everything, and there'll be time to answer questions. If you find that you have questions as I'm going along, feel free to type them into the questions window. Someone will be online to help answer those, and then we'll try and answer everything at the end. So first, a little bit about us here at SDA, or Structures.Aero. SDA was founded in 1997, and we provide expert aerospace structural analysis. We serve a wide variety of industries, but we really specialize in composites and developing strong and lightweight structures that are readily manufacturable. We can provide low-level support all the way up through developing test plans and advanced stress analysis. Typically, we support small to large UAVs, manned and unmanned space and aircraft. And from time to time, we do some work on naval structures. Our team here consists of about a dozen engineers, ranging from a bachelor's level all the way up to PhD, and we're located in Sterling, Virginia, just a little bit north of the Dulles Airport. Here's an example of some of the projects we typically support. Just to highlight a couple, one of the main projects is the Orion crew module. And then as well as the heat shield on the Orion. And here you can see a couple of the UAV aircraft that we've worked on. So along with the engineering support that we provide, we also partner with Siemens. We are a value-added reseller. And we also provide first-line support, especially with Femap and Nastran. But here you can see a few of the other softwares that we sell and support. And along with that, we are also work with Collier Research to sell and support HyperSizer. So now let's jump into it. So first things first, there's data services, and then there's the data surface editor. So data services are used to apply various loading conditions, and there's a few predefined methods that you can use to apply these. And the editor is used to create these data surfaces, create and edit and manage. A lot of helpful information can be found in the commands PDF. That's found in the root install directory of Femap. Under PDF, you can find the commands file. That has a lot of really useful and helpful information about the data surface directly in section 726, Tools, Data Surface Editor. Here are a few of the options when you're working with the data surface. You can use this button here to create and load data surfaces, this button to save them. This is the button used to edit them. And then here you can copy and paste entire data surfaces from one model to another. So a few of the different, there's a few options when creating data surfaces. The two we're going to highlight today are an output map data surface, which allows you to take output from one mesh and then apply that load to another mesh. And an arbitrary 3D data surface, which takes point in space, and then that point and a value, and it uses that to distribute the load using an inverse weighted interpolation method. So for our first demonstration, what we're going to do is we're going to take output mapped on our coarse FEM here, and we're going to map it as load into our more fine mesh here that's blue. So we'll start in Femap with our source FEM. So what we have here is we just have an output set that contains pressure data on all of these elements. So we're going to start. I don't have the data surface. Give me 1 second. Oh no. All right. Give me 1 second to work through this, and then we'll get right back at it. Okay, sorry about that, everyone. A little bit of a technical issue having the data surface available to us. Okay, so now, first thing is we open the data surface. So if you saw, there's a little button here right under geometry. You click that, you open up your data surface. So now to create our data surface, we click this drop-down menu, and we create an output map data surface. So here, we're going to give our data surface a title. We need to pick an output set here. This output set corresponds to the pressure information on these elements, and we pick an output vector. Okay, now we're going to go look at our options. So here are your options for what to do for locations that don't directly correlate to a map. We can set it to 0. We can set it to a specific value. We can extend the closest map point. We're going to leave it on the default, which is to interpolate, or we can make no output for that location. Other option is going to be the mapping tolerance. So what this does is this finds the closest link from the target map to the source, and if it's within this tolerance, it won't interpolate. It will directly apply the source load to the target. But if it's outside of this, then it will interpolate. Okay, so now we just hit OK, and we have our data surface. So I'm going to save. I'm going to close. So now I'm going to open. I'm going to reload. I'm going to get the data surface. So I'm going to copy this data surface. I'm going to open my other model. And I'm going to paste it. So now I have the data surface in my new target model that I want to apply the load to. So I'm going to come in. I'm going to create a new load set. Now I'm going to apply an elemental load to these elements. So first I select my elements. And so now you can apply a value of 1. And so what this is going to do is this is going to scale the information in the data surface. So if you apply a value of 1, it's going to scale it by 1. It's going to directly apply that information. If you do a value of 2, it'll multiply it by 2. If you enter a half, it'll give half the value in the data surface. So method, we're going to choose data surface. Then we choose our data surface demo. So now another option we have here is we can do at corners. So as it is now, what this will do is this will apply a centroidal pressure to the elements that we have selected. If we do corners, and then we copy the same format, a value of 1, data surface 2, what this will do is this will apply pressure at the corners of each element. And so depending on which method you want to do, those are your two options. For now, we're going to leave it a pressure value of 1 as a centroid pressure, hit OK. Now we need to pick an element face. So we're just going to go by face ID, this face here, face 2, front face. Okay. So it's a good practice, a good modeling practice is you're going to want to make sure that all your element normals are facing the same direction and facing the correct direction so that you know which way you're going to be applying the load. So now a useful tip is we want to go in and we want to actually visualize what pressure we just applied. Kind of make sure it's right, make sure it's what we're expecting. So a good tip to do that is you can come in here to your results, manage, create a new output set. We're going to call this demo load visualization. Now making sure that the load you want to visualize is active and the output set that you just created is active. You're going to come into model, output from load, pressures, select your elements, and now we have a visualization of the pressures that we've applied. So there are two ways we could have done this. There was that way where we went in, we created a data surface, we copied it, we brought it into this model. But new in 11.3.1, we can directly do that without touching the data surface. So you'll need two things. You'll need source information and target information. And you'll need to have both of those mod FEMs open in the same instance of Femap. And then starting from your target mesh, you'll come in. First, you'll need to create a new output set. We call this demo load 2. We're going to come in and you're going to use the model load map output from model. So from here, we select the model. That is our source. So we're going to choose our source model. Results on group. And so what this is this is a group in the source model that contains the elements from your source mesh, which elements you are using that contains the output to apply to the new FEM. So that, for us, that is the coarse FEM. Output set, very similar to the previous method, is we're going to pick the pressure with corners, the same output vector. You'll notice that the options are the same here. We're going to keep it on interpolate using the default tolerance. So now here at target, we have two options. We can directly create a data surface here in this model, or we can go directly to model loads. So we're going to do the same thing, elemental, and here we have a couple of different options. We can do pressure directly, option 1, which will map centroid pressures, or we can do pressure at corners. And so what this is that second method where you can apply the pressure to the corner of the elements. So now we hit OK. We need to select our target elements. We're going to hit previous, these elements here, OK. We select our face, OK. And as you can see, we now have directly mapped the pressures onto our new model from the old one without going in and creating a data surface. So now there were two different methods that we used, that we highlighted, and that was using the centroid data, only using the centroid data, and only using the corner data. So here is just a quick comparison of the two methods. Here on the right, we have a map of the original pressure distribution on the coarse FEM. And here in the middle, we have our new map of the pressure distribution on our fine FEM using the corner data. And on the far left, we have the map on the fine FEM using the centroid data. So if you look at the corner data, you'll notice that it's a direct map. It matches fairly exactly to the original FEM, even going, so here we in the bottom left of this pink region, we have a sharp line in the corner of this element. We have that same line here in the corner data. Using the centroid data, it's a little bit more, the load's a little bit more spread out. It kind of averaged the data, and we have more smooth contours. So either one of these is fine. It's just depending on what exactly you want from your loading. Here with the centroid data, we lost a bit of the peak information, especially here in the upper right, and a little bit on the lower left. But it is just a more averaged spread look at the information at the load. So next, we're going to look at a little more advanced example with spreading load onto a wing, not just a simple plate. So for this method, we're going to use the arbitrary 3D data surface. And so what this is here is on the left, we have a small subset of the points that we're going to use to create this data surface. And it gives an X, Y, Z location and a pressure. So with just a point in space and a scalar pressure, we're going to directly map onto our wing FEM here. So because I had to close Femap, I'll need to open this real quick. Okay. So here we have our wing, and we're going to start in very much the same way. We're going to open our data surface editor. We're going to come in and we're going to click arbitrary 3D data surface. So here we have a couple options. We can one by one enter our data points, but this can be very tedious, especially if you have a lot. In this case, we have about 1,200 data points. So a nice feature is you can directly copy and paste from Excel. So here we have all of our pressure information. We're going to copy that, come back into Femap, directly paste it. So now we're going to go look at our options. So you'll see the same, it's the same options box, but different, there are different dialog boxes available to us. So here we have the same mapping tolerance option, which we're going to leave as the default. Then we have our percent of location to include or the min locations to include. So what this is this tells Femap how many points to include when interpolating, when it's spreading the load. So we're going to knock this down to 0, because what this is that's the percent of points you want to include. We're just going to give it the min locations to include. So what this will do is this will pick the closest 3 points to our element and map that load to them. So we can either do, there's a few different ways to do this, and in a minute I'll highlight in the PowerPoint some of the different options. But it's just kind of depending on what exactly you want to capture. So in the PowerPoint we go between 1 and 3. So I'm just going to leave this here as it is. We hit OK. We have our data surface. So then if I wanted to apply the load, it'd be the exact same way I did before. You come in, create a load, go in, create an elemental load, select your elements, and you go from there. So let's hop back into PowerPoint. So this first map here, this was with the option of including 3 data points to interpolate from. So if you look here, there's some of these regions where there's kind of a disconnect. And you'll notice it's mostly towards the trailing edge, where some of these points don't match up with the elements next to them. It's not a very clear contour. It's not very smooth. And so now if we look, this was done only including 1 location. So what this did is this found the closest point and it directly applied that pressure. And so if we look at this, there's kind of clear squares of the pressure distribution where it just found the closest point here, applied that pressure. And so something to highlight is that if we look at our mesh here, and if we zoom in towards the trailing edge, you can see that some of these points between the upper and lower surfaces, the closest 3 points aren't necessarily all on the upper surface or all on the lower surface. So depending on what you have your options set for how many points you're going to interpolate from, it can greatly change the load that you apply, and it can make it wrong. So for this method here, it really would have been best to split up the load, only apply it to the upper surface, only apply the upper surface points to the load on the upper surface, and then the same thing for the lower surface, where we're only applying the pressure on the lower surface from the points directly mapping to the lower surface. So if we go back into PowerPoint, maybe, we can see this was with the pressure applied separately to the upper and lower surfaces, including 3 locations to interpolate from. And as we can see, it looks very similar to when we just applied interpolating from 1 point, but it's a more smooth contour. The pressure is applied, it's more averaged over the surface. And if you noticed here, the sum Fy was 470 pounds, which was the same as when we only interpolated using 1 point. But in a less academic example, the results can be much worse and more wrong than in this case. So that concludes all the demonstrations for today. I just want to highlight an additional resource if you're new to Femap, if you're looking to learn more about Femap. One of the engineers here at SDA, Eric Gustafson, he wrote a book called Learning Femap. It's a really good resource just to kind of A, learn Femap, but B, just get more knowledge about how it works, how to do things. So if you have any questions about that, you can go to learningfea.com or contact Eric directly. If you have any questions as far as software goes, feel free to contact our sales manager, Marty Civic. He'd be more than happy to answer any questions you may have. If you have any questions about the webinar, feel free to contact me. My contact information is on the screen. So now we'll have time for any questions. So if you have them, please feel free to type them out. So we have a question about what is the easiest way to define a data surface based on equations such as a pressure gradient. So I would say the easiest way to do that would be if you open the data surface. The easiest way is with, I would say, a mesh data surface. And so what this does is you can directly feed it the elements and nodes you want to use, and you can give it an equation. So you would just have to know, where your model is, and then you can directly give the equation in with this method. All right, everyone. I don't see any more questions, but if you do have them, again, please feel free to email me or contact our support team here at SDA, and we'd be happy to help you. Thank you, everyone, for attending, and enjoy the rest of your day.